Hi everybody, I'm Jim Hudspeth with Reed Electric. This is Marvin Houston with Reed Electric and Dan Custer.
So this presentation is fairly short, so if you have any questions, go ahead and text 775-433-9390 and we'll do the question and answers probably after the presentation.
Today we're going to have a short training class on vertical motor Endplay settings with angular style contact bearings. There's basically two types of vertical motors, hollow shaft and solid shaft, and they can both come with this bearing arrangement. They can come with multiple stacks of angular contact. They can come in different types of stacks, back to back, in tandem, and so on. There's also spherical rollers. We're not going to talk about that other than just showing you one that illustrates what they look like, as you can see in the video right there. One of the big discussions is on types of oil and weights of viscosity and what type to use. We pretty much normally try to standardize up here with a 32 turbine oil for up to 100 degrees Fahrenheit. Most of the time that includes 1800 to 3600 RPM motors. When we get into your larger type of bearings or spherical rollers, we start talking about 68 and 150. 68 is good up to 40 degrees Fahrenheit. Anything above that should be 150 weight viscosity for the spherical roller type, or even the heavy ball type.
So in colder weather, can you keep the 150 in all year round?
You can, because of the ambient of the motor raising temperature, but what they're trying to say is that that doesn't conduct the heat as well. So it runs cooler with the thinner oil during the winter. The 150 is really recommended for summer, especially where it's really hot outside. So if we've got 100 degrees and you're down in the Heber area or Calexico or any of that area, you definitely want to be using a 150 all year long. The difference is whether you can use a mineral oil or a synthetic. It really gets a little strange because US will recommend water cooling and synthetic oil only. General Electric will go in there with water cooling and does not want you to use synthetic oil. Both same type bearings, both same horsepower motors. Pretty much standardized on the synthetic in my opinion only, because we've done so many experiments with temperatures and running motors and letting them run for hours and recording vibration and temps. We can see a big difference in the synthetic oil versus the mineral oil. We don't really recommend too many oils or greases to customer, other than what we tell them here is that we use nothing but Polyrex EM for the grease. And for the oil, we recommend the Mobile synthetic. And again, that basic is on the type of motor they have. Some of these have different rubber base, and the synthetic oil can have an effect on the type of material that's in it.
So if I have a foaming issue with my vertical, do I have to specifically ask the oil company or wherever I buy my oil to add like an anti-foam?
Absolutely. If you buy the oil, you want to spec that it has an anti-foaming agent and an anti-rust inhibitor in it. You can buy it without it, and it will foam and it will rust if you don't have those two additives in it. It doesn't come automatically in the type of oil you think when you buy it.
Okay.
We're going into a short video.
Hi, I'm Marvin with Reed Electric and Field Service, and today I'm going to show you how to set Endplay on a ball angular contact thrust bearing. So you're going to need a couple tools with you. One, a dial indicator. Two, a hollow tube to reach the steady bushing inside the shaft. And three is a jack. So what you want to do is set up the dial indicator on top of the shaft before jacking it up. Start to jack it up, and then as soon as the dial indicator stops, you know that your lower bearing has hit the bearing cap. You don't want to go too high because you could have the possible damage of breaking your bearing cap or damaging the bearing. So once that's said and done, you want to grab your spider washer and the shaft nut, and you want to tighten these all the way down to take out what it's called is no Endplay. Doing this for a while now, I've run into several different problems. One of the problems is cocking the bearing cap to the shaft and then trying to set Endplay. What happens is you get a misreading of Endplay, and then when you go to try to test run it or even install it, you have the possibility of damaging both bearings. So once your shaft nut is all set up, set the dial indicator back to 0, release the jack, you might have to do this a couple of times. The differences between a US and a GE vertical hollow shaft motor is the Endplay settings. On a US, which we have here, the tolerance is set between 5 to 10 thousandths, and on a GE, it's between 2 and 5 thousandths Endplay. So you might have to jack it up and lower it a couple of times. So right now we have the Endplay right at 10 thousandths. We'll put it right in the middle. And there you have it. Endplay is set at 9 thousandths Endplay. And that's how you set Endplay on a ball angular contact thrust bearing.
So Marvin, one of the things I'm curious about is, have you actually had one of the verticals sitting on a test pad, go to run it and actually hear anything go click or clank and have vibrations all of a sudden go from rough to smooth, or any of the shaking stop from having that happen?
Yes. On first startup, once it's starting to actually get up to speed, you can almost hear it as if the lower guide bearing kind of reset itself into uncocked position. Yes.
Yeah, because your bearing was actually in there at a little bit of a cock, and even though it stayed with you setting the Endplay over on the pad, moving it and setting it down and then starting it up and having that bearing actually start to warm up and the housing expand a little bit, go back into position, and then all of a sudden have vibration readings that are much better, and noise problems go away. So you can tell that.
I have a question from LA. Is it okay to lift the carrier with the crane rather than using a jack to lift the shaft?
You shouldn't do that. And the reason for it is you have a lot more control by using the jack, because you can jack it up with your fixture inside the hole. You can make these all different types of ways. You can make it with cones, you can make them different versions, so that when you jack it up, you're actually jacking the shaft and seeing it. You can have one hand on the motor and jacking it. You can actually feel the motor start to lift off. You know you're all the way up. You can do that 2 or 3 times before you actually go to set the Endplay, and you know pretty much that the bearing has moved in the housing, is moving where it should be without being cocked.
And that also gives you an opportunity to watch and make sure that the shaft is sliding through the carrier. You don't want the shaft to bind on the carrier and start raising your angular contact bearing up and down to give you a misguided end play setting.
Let's say we go from one extreme to the next. If you were using the crane to lift this up and you had a 2-pole machine that's 3,600 RPM with a locking ring on the outside of the top bearing, you wouldn't be doing anything. You'd be lifting up your motor or lifting up your carrier, and you'd be trying to pick up the whole motor because the locking ring around the outside is stopping the bearing from being able to move on the carrier. So by using a jack method, I think that it's a lot better. You have more control over it. You can feel it easier. You don't have to wait for the crane because everybody else has got the crane, and you can continue to do your job, but I think it's a lot better way to do it.
You're also you're saving the guide bearing from putting on a lot of stress. You're also saving the bearing cap from a possible break.
That's a good point. A lot of these bearing caps are really thin material. We've seen bearing caps come in split in half where they've had some upthrust and broke the caps. Only thing left is the 4 bolts sitting there with pieces of bearing cap on it. So it doesn't take a whole hell of a lot for it to actually break the cap with too much pressure up against it.
And you can find more problems if you have a problem with the vertical by using a jack, because you can actually see everything move and you can feel it with your hands.
Very good point. Another thought is that if you have a bearing that is designed to shoulder onto the shaft, so again we're talking like a 2-pole solid shaft, the bearing carrier goes down until it hits the shoulder, then the nut goes down, there is no end play. It's completely tight at that point. Any other questions you guys in LA might have?
I don't see any yet. If there's any other questions, you can also call if that's easier.
Doing a hollow shaft versus a solid shaft vertical, you really want to make sure where you're placing the dial indicator. You don't want to set it on the carrier because the carrier's not going to move. Only the shaft moves. So if you're setting the dial indicator on the carrier and you're thinking that you've got an adjustment, you could have it too loose, you could have it too tight, because you're not going to get any type of movement.
You're moving your shaft up and down through the carrier. Your indicators on the carrier, you're going to get 0.
Yeah,
you're
so
not going to have anything other than what small amount of movement is in the frame assembly.
Yeah, so make sure wherever you're putting your tools, just put them in the proper place. And for a solid shaft or a hollow shaft vertical, you can have up to 3 to 4 bearings on the carrier. Your end play is still going to be the same. So you don't have to worry about having it looser versus tighter. It should all still be the same type of end play setting.
Another thing I'm going to bring up, just since we're talking about bearings and thrust bearings, one of the angular contact bearings that seems to be working real well for us here in Reno is the Koyo. It's a newer design that allows it to pump oil through multiple stacked bearings at a much faster rate. So the drawing for this particular bearing starts off with showing you a bearing that's normal, like a normal Koyo, versus the Koyo that is now designed with much better oil flowing through it. And they can show 5 bearings being stacked or 4 bearings being stacked, oil all the way through, while the oil is only to the 2nd bearing on the original design. So I'm saying that the oil can flow through 4 bearings faster than it can the first 2 of the 4 stack on the old style. You're running 2 bearings in this type of motor with no oil until it gets the oil up to it. And it doesn't take very long to smoke the bearings.
So how can you tell between the 2 style of thrust bearings which one to properly use or not?
The Koyo has a special call out for it. Richard, I have sent you that drawing along with Rowdy. It's like a Y or a DY on the end of it, but the big fact is that you can see it in the bearing. When you turn the bearing, and this is the large support thrust here, so this is the large part of the race, this is the narrow part, it's open. I mean, this used to be real wide metal at the bottom and a very small amount of gap between the inner and outer race that allow the oil to pass through it. The new design Koyo is this far as being open on a bearing this size. So it's really able to pump the oil very fast through a multiple stack.
Okay.
We have another question, and that is, why are the GE and US specs for Endplay different?
It's a good question. I don't have an answer. They're the same horsepower, the same bearings, and yet one recommends synthetic oil, one doesn't. One recommends synthetic oil and water cooling only, one doesn't. So I don't know where GE's got it in their mind that they shouldn't use synthetic, other than that they have a problem with maybe some of the materials that are constructed. Let's say the paint in the housing starts coming apart with the synthetic oil, starts getting a red or a white paint mix into the oil look. I don't really have a good answer for why GE doesn't like to use synthetic, yet US is only recommended using it.
Do we have recommendations based on our experience?
I would say to use synthetic oil.
Yeah.
Synthetic oil, and as well I would make damn sure that you
As far as the Endplay?
the Endplay. So let's talk about Endplay for a moment. We both have a customer. We set the standard here to be 12 to 18 thousandths. The reason for that is we have a castle nut up on top with the washer, and it's got a space maybe 2 inches from the locking points. So if we're at 12 and we wanted to go to the next, we're in the middle where the tab's at, and we need to be over here. By the time we take that large enough nut and rotate it to where we could get to the next lock point, it could be as much as 18. So that's why we give them a tolerance to go from 12 to 18, because you don't know where your nut's going to be, where you can bend the tab up at the time. Keep in mind that every time the motor starts, the Endplay is pulling down pretty hard. So you could have a mechanical seal like that guys use that is anywhere from $5,000 to $10,000 depending on the size of the seal, slapping the faces every time you start it. And they had problems where they went through multiple motors at one of the locations up here. The manufacturer had been US, and the first motor that we got in, we couldn't get the carrier off the shaft. It took a 20-ton jack to pull the carrier off. How the hell did they set the Endplay? The second motor they called us on, they said they could see the shaft move 1/8 of an inch down every time they started it. But we got it in. It was 150 thousandths Endplay setting. These are brand new, just installed motors. They went through 5 seals on the first one trying to figure out what was going on. So if they got 5,000, that's 25,000 bucks. If it's 10, it's 50,000. Real quick damage just because of the Endplay problem. I don't know if that answered the question. I hope it did.
Any other questions?
Richard, I have a question for LA. What do you guys currently use for adjusting Endplay? And I'm jumping the gun a little bit, where you have a spring-loaded bearing. I don't care if it's angular contact or if it's spherical roller. What are you using for your Endplay bar across the top or I-beam or whatever? I've not got a chance to see how you guys set the Endplay on one of those. We have the bar up here with locking points and chains that go to the vertical motor on the ears that we put our jack fixture in between and our jack. But I am just curious to see what you guys are using up there. We've had problems with setting Endplay because of the frames putting the indicator here and actually having the frame bowing from the jack and the chain assembly that we're using. So we got some false readings.
All right, just a second. Rich, let me put you on speaker.
So we have like an H bar that we run all thread through, and then also and then we have a little fixture to put the port of power in there to compress everything downwards, and then we secure it with we're using the chains right now, or yeah, we're in the process of making a new fixture that's going to be a little better, that has some like R buckles to make the chains adjustable and the width adjustable and things like that.
Okay, I understand. Again, I'm going to just recommend to you guys kind of watch it. Every time that we've had any discrepancies on Endplay settings, again, our chains are coming down around to the ears, our bar is going across the top. We have what looks like my hand as a fixture with our jack assembly on top of it between the pipe or the I-beam where we're jacking up. We can actually see the bracket trying to flex, and it can flex 5 or 10 thousandths real easy.
Very easy.
Very easy. So what was happening is we were sending some of our verticals out with the lower bearing up against the cap preloaded and would not lower when they put the weight on top of the rotor. So the bottom bearing's going to die no matter what. So if you guys see a lot of bottom bearing failures on any of the motors you've had in the past, especially if you went up with one and 6 months, 8 months later it came back in and your bottom bearing is cratered, you better start looking at your end play.
Any more questions? Okay, I think that's it for today. Thank you.
Guys, thank you.
Thank you, guys.